All right, so part 3 of the evolution lecture. We've given a bit of the background to Darwin and then a bit of a summary of what he thought and some of his arguments. Now we're going to look at the aftermath of the Origin of Species in 1859 and people who supported him and various kinds of opposition that he got, scientific and religious. Okay, so under the heading of religious or clerical opposition to Darwin, we have, for example, Adam Sedgwick, who's sort of representative of one kind of school of thought here. So Sedgwick was, thought parts of the book were pretty good. I don't know specifically, but maybe, for example, the part about evolution generally, for example, how the Galapagos species was similar to the American species, but not the same because they had changed a bit since they came over the water. But he was unhappy with the idea of natural selection because it seemed to be directly contrary to the idea of God as designer. And the idea of evolution as sort of planned and fulfilling God's purposes and so on. Here's a little quote from Sedgwick. It, that is the theory of natural selection, repudiates all reasoning from final causes and seems to shut the door on any view, however feeble, of the God of nature as manifested in his works. From first to last, it is a dish of rank materialism, cleverly cooked and served up. Yeah, I mean, if the new features in a population emerge just through kind of random variation that is selected on, it seems to contradict the idea that God sort of planned it and sort of engineered it that way. Now, we're going to talk about how other religious thinkers didn't see a contradiction there, but certainly there's an apparent problem. All right. Now, even people who weren't religious often saw a conflict between Christianity or maybe theism more generally, any kind of view that involves God as creator, and the Darwinian view. Here we have a part of a speech by someone called Ingersoll, an attorney and a famous American orator. And you can see that he's against religion. And furthermore, he's kind of using Darwin as a stick, as a weapon to attack religion. Notice I've put a couple of things in bold here. Charles Darwin destroyed the foundation of Orthodox Christianity. Religion and science are enemies. One is a superstition, the other is a fact. One rests upon the false, the other upon the true. One is fear and faith, the other investigation and reason. Okay, and there's more along those lines. And it's particularly his doctrine of the survival of the fittest. I mean, it does mention evolution there, but particularly the doctrine of the survival of the fittest. So what we find in a lot of thinkers, I'm not actually sure about Sedgwick at this point. He might still be opposed to transmutation as well as natural selection. But many thinkers were okay with the evolution or transmutation, but they drew the line at natural selection. Anyway, here's sort of some classic oratory about how religion and science are enemies. We talked about previously, and a lot of people sort of projected this opposition backwards onto the Galileo affair, as I said before. Okay, so on the other side, among the religious thinkers are people like Baden-Powell, okay, better known as the founder of the Scout movement, but also a scientist. Basically, Powell, similar to, I mentioned Nicole Oram in the Middle Ages, who said that, bringing the supernatural into science is kind of like the last refuge of the weak-minded or something like that. So Baden-Powell similarly was opposed, if you're going to explain things in natural history, that is, the history of life, you don't want to appeal to primary causation, which, if you remember, is God's direct action, sort of like miraculous action. And it was sort of that idea that God should be a very competent clockmaker who builds the clock and then it doesn't need any tinkering. It doesn't need any fixing up, but it can work for a very long time all by itself. Yeah, so that's the idea that God should endow his creation with sufficient powers. It shouldn't be an impoverished creation that can only do a very little by itself and constantly needs help to get any tasks accomplished. It's a powerful creation. God has given it those powers because he's a good and wise creator, that kind of idea. It shouldn't need any help. And there's plenty of scientists who are theists who would take this line today. Howard Van Til comes to mind anyway. All right, now another important person is Asa Gray. Now, Asa is the first American we've considered. And so he is largely responsible for smoothing the acceptance of Darwinism in North America, okay? So he's a friend of Darwin. There's a lot of correspondence between Darwin and Gray, also Hooker, who I think was one of the X Club, along with Huxley and Spencer and the others. So he's a top-class botanist and also a Christian. In fact, funnily enough, Asa Gray actually somehow brought Louis Agassiz over to America, who was an anti-Darwinian, and the two apparently debated a few times in America on Darwin's origin. Yeah, so he gave a very positive review of Darwin's theory. He arranged for it to be printed. He supported it in public debates. He did various things to boost Darwin in America. And remember that Darwin was kind of a sickly guy. He couldn't really publicly defend his own theory, even in London, much less across the ocean. So it was kind of useful to have someone like Asa Gray fighting for him. Although in the correspondence, Gray wasn't entirely happy with the theory, particularly he saw potential conflicts with the idea of God as creator, which is part of Christian theology. So there's some interesting correspondence there. I'm going to look at a little bit of that with you now. Yeah, this is Darwin responding to Asa Gray's. So this is actually in a paper, not a letter, but so Asa Gray has apparently said that variation has been led along certain beneficial lines, like a stream along definite and useful lines of irrigation. So that that metaphor seems to be that the stream in this case is being described as not just sort of going wherever it wants, that somebody has kind of dug a channel for it, or maybe several channels in a field. Okay, because that's where the crops are to be planted, and so that's where we want the water. And so once the channel's already dug, of course, the water will follow that path that's preordained. So it seems to be some kind of idea, yeah, it mentions the word preordained here, that God has somehow set things up so that the path of evolution is preordained by his design. Okay, and so it's not just a matter of luck that, for example, human beings appeared at a certain point, descending from some ape-like ancestor. But Darwin's not happy with this because he sees that mechanism for evolution is actually in conflict with his own mechanism. He says it would basically make his own mechanism superfluous. If you look at the text there. By the way, this proposal by Asa Gray nowadays is sometimes referred to as a front-loading theory. That is that somehow, the first cell or the laws of physics or something is set up in a way that the evolution of life is deterministic from that point, similar to the way that the development of an egg, let's say human egg, into the adult phenotype, the adult body is sort of predetermined by the sort of genes and whatnot within the egg. It's that kind of idea applied to evolution. Yeah, and he says that, well, if that's going on, then there's no need for natural selection. Natural selection must appear to us superfluous laws of nature. Yeah, and here again, he's referring to Asa Gray, or he's writing to Asa Gray. He says, I can't see the evidence of design and the goodness of God and so on. For one thing, there's too much misery in the world. In another letter, Darwin refers to this, I think it's a wasp, some kind of insect that lays eggs in the body, a living body of another creature. And at a certain point, these eggs hatch and they turn into little maggots or something, and then they like burst out of its unfortunate host, right? Presumably killing it. It's kind of like that movie Alien by Ridley Scott. If you saw, at a certain point, this creature bursts out of a man's stomach. Okay, it's kind of like that. And this really happens in nature, and Darwin finds that very distasteful and not sort of something that a wise and good creator would want to set up. Okay. Yeah, and he says he's kind of stuck, apparently, Darwin, at this point. He doesn't see it all as coming from a wise and good creator, but he doesn't see it, as he says, just everything as the result of brute force. He's trying to find some sort of middle ground, that maybe there are designed laws. Okay. So you set up good laws and then you let the rest run according to chance. That's the sort of the best he can kind of come up with, although he says it doesn't satisfy him. Anyway, certainly he's not going all the way with Asa Gray. So let's move on to another Catholic here, Mivart. So he didn't have a problem with evolution. Okay, so he's one of these people that definitely makes a separation theologically and I guess scientifically too, between evolution itself and the theory of natural selection. Nowadays, we tend to sort of think these are the same thing, but certainly in the 19th century, there were a number of different theories of evolution, and natural selection was only one of them. Actually, that went into the 20th century as well. Yeah, so similar to Baden-Powell, he says he's okay with secondary causation. Okay, if evolution is some kind of natural process by the sort of God-given powers of created objects, yeah, God created them by conferring on the material world the power to evolve them under suitable conditions. He's fine with that. So he doesn't actually seem to have any religious trouble with Darwin's theories at all. It seems to be more of a scientific problem that he has. He attacks natural selection for its alleged inability to count for what he called incipient stages. So these are kind of like half-evolved things. And this has been a familiar sort of creationist argument ever since Mivart. So, you know, the creationists will imagine, okay, so you see this eagle with these beautiful wings and it's soaring around the mountaintops. But, you know, that evolved from some creature, some kind of dinosaur without wings. So then you imagine the sort of the half-built wings, these little stubby things, you know, that are only about 6 inches long, and they're like flapping like mad, you know, but it's not getting off the ground. Okay, so this is the problem of incipient stages, or like half an eye. You've got some creature, poor thing, with, you know, an eyeball, and you know, maybe it's got a lens, but it's got no retina or something, and so it's completely blind because all the parts aren't there yet. It's waiting for another few million years before the rest shows up. So this is the kind of worry that Mivart has. Of course, there have been plenty of responses to it. Well, let's just look at Mivart's, at Darwin's own response. Darwin took this problem pretty seriously, and it did, you know, did spend some time trying to satisfy Mivart. And this argument, yeah, I mentioned that it's sort of a creationist favorite. The big champion of it in our own day is Michael Behe, sort of an intelligent design theorist. I'm going to mention it a little bit later. Yeah, so Darwin's response to Mivart mostly focused on the eye, which seemed to be a particularly hard problem to explain, you know, how you get all the way to the functioning eye and sort of through maybe non-functioning stages. Well, all the details aren't here, but Darwin noted that in the natural world, there are a variety of sort of partial eyes, you might call them. There are creatures sort of with half an eye that get on perfectly all right. For example, some simple species have just sort of photosensitive, light-sensitive patches on their skin, so that at least they can tell whether it's light or dark, and maybe if a predator passes overhead, it casts a shadow on them, and then they know that they're in danger and they kind of scuttle away. This kind of thing. And there's also some creatures with pinhole camera eyes, so there's no lens. I think the nautilus, which is kind of like an octopus, same family, they have these pinhole camera eyes, which are not as good as eyes with lenses, but they're better than nothing. Yeah, so he said, we've got a bit of a sequence here, and then if you can sort of imagine further intermediaries. So he says, if numerous gradations from a simple and imperfect eye, maybe going all the way back to a light-sensitive spot, to a complex and perfect one like the eagle, if we can show that there's this, sequence of almost identical, just each one slightly upgraded from the previous one, if we could set this up, then the difficulty of believing that a perfect and complex eye could be formed by natural selection, even though it seems impossible to our imagination, should not be, a serious problem. Again, it's always stated in conditional form, if we can show such a sequence to exist. As far as I know, Darwin didn't do that, and I know others since then have taken on the task. Nilsson and Pelger, a famous paper on this, although they didn't get too close to what Darwin is imagining here. It's just more like a sketch that they accomplished. But yeah, that was the response, that what good is half an eye? Well, it sort of depends which half. Okay, that's roughly the idea. And Dawkins too, Richard Dawkins, another contemporary, sort of defender of Darwin, has sort of raised the question: what good is half a wing? Well, it might have various functions. I mean, it might be some kind of radiator that cools the blood, for example. It might, even if it doesn't actually allow you to fly, it may allow you to glide. And even if it doesn't let you glide, it might sort of break your fall a little bit. It might allow you to jump off a slightly higher branch without breaking your leg, and so on. So that there might be some functionality even to a partially formed wing. That's the idea. Now, I want to draw attention to this passage, which is interesting. He says, if it could be done now with the eye, we don't really know whether there is such a sequence of eyes that would fit his requirement, that each one is sort of easily reached from the previous one by a very small change, and such that along the sequence, it's getting progressively more and more functional, so that natural selection will sort of push the population along that sequence. We just don't know if there is such a sequence. No one's ever managed to construct one. But look how he sets this up. He says, if it could be demonstrated that any complex organ existed, like the eye, for example, which could not possibly have been formed by these numerous successive slight modifications with increasing function, my theory would absolutely break down, but I can find no such case. Yeah, no, that's interesting, because he's not saying my theory predicts that the eye would exist. What he seems to be saying is that nobody can show that my theory doesn't predict that the eye exists. We can't find any clear counterexample to the theory. So he seems to be asking something like, has anyone shown that my theory does not predict the data? And the answer is no. But in science, usually, the burden of proof in science, as I mentioned in that case with Isaac Newton trying to show that his theory predicted the lunar motion, and he couldn't do it. He didn't have good enough math skills at that time to actually do the calculations. So Newton had to say, well, we just don't know if the lunar theory, if the moon is explained by my theory or not. So it seems to me that Darwin should have really said the same thing. We just don't know if my theory predicts anything about biology. unless we can construct such a sequence, then, you know, it's just a question mark. But he seems to sort of reverse the burden of proof and saying my theory is adequate unless anyone can show the contrary, which is pretty unusual in science, I think. I don't know if it's different in biology, but in physics, you wouldn't really get away with that. Yeah, so another kind of criticism for Darwin. Now here we're talking about not just the theory of natural selection, but also the theory of evolution more generally, or transmutation. But the problem is more severe for natural selection. Basically, we don't see evolution. We can't see it. There is no sort of direct evidence of it. I mean, if you look at human history, actually, you can see changes, like you can see from one season to the next, slight changes, for example, in the beaks of Darwin's finches on the Galapagos. But you can't see the sort of the major transitions, of course, which do take millions of years. Of course, trying to see natural selection is even harder. Certainly can't see that in the fossil record. I'm not going to talk about trying to find statistical signals of selection in sort of comparing genomes. But anyway, yeah, stay out of that. So his Agassiz, remember, he was a contemporary of Darwin and Asa Gray, debated Gray in America. And so he's saying that basically, if you look at the fossil record, it's sort of divided into a lot of geological periods. You probably know the names of some of them, the Devonian and the Jurassic and the Triassic and the Cretaceous and so on. So he's saying between these periods, you see changes. But within the period, you see so-called stasis. That is, things basically stay the same with maybe very minor changes, but nothing very significant. Now, you know, he says that the naturalists, or some naturalists, suppose that these they suppose that there are, you know, changes taking place. But he says this is a mere supposition supported neither by physiological nor by geological evidence. So we don't really have any direct evidence of transmutation or evolution. You know, the fossil record is probably more consistent with a sort of progressive creation type model, he's saying. Now, more recent paleontologists, as fossil experts, have said similar things. Stephen Jay Gould here. Every paleontologist knows that most species don't change. That is, you know, you see, as Agassiz described, you see, you know, nothing happens, and suddenly there's a new species. You don't see the gradual blending from the old species to the new. That's bothersome, brings terrible distress. They may get a little bigger or bumpier. They remain the same species, and that's not due to imperfection. Now, he says that's not due to imperfection in the fossil record. It's not just that we haven't collected enough fossils yet, that it just looks that way. We now have, you know, millions of fossils, and the fossil record is now essentially complete. And, you know, we still have gaps. And so it's not just an artifact of our limited number of fossils we've collected. His Eldridge saying a similar thing. The observation that species are amazingly conservative and static through long periods of time has all the qualities of the emperor's new clothes. Everyone knew it, but preferred to ignore it. Paleontologists faced with a recalcitrant record, obstinately refusing to yield Darwin's predicted pattern, simply looked the other way. So it didn't sort of change a lot then between the time of Agassiz and you know, the 1980s anyway. Now, Gould was himself a believer in evolution and at least accepted, you know, some of Darwin's model. He didn't accept it all. So he himself proposed that evolution must occur when sort of special conditions are present, and when it does occur, it occurs very rapidly, so that it occurs kind of in the blink of an eye, geologically speaking. So that's why you don't actually sort of catch it. It's a bit like, you know, if you have a security camera that's only running at, you know, 4 frames per second, or if you have a normal security camera where one of those superheroes, what's his name? Is it the Dash or something from The Incredibles? Anyway, he's fast enough that he can do a lot between one frame and the next. Okay, so it appears like he just jumps discontinuously from one place to another. But it's just that your camera is not fast enough to catch the intermediate states where he's, you know, passing through every point in between. So it's kind of like that. The geological record is like a very slow frame rate, and so it doesn't catch this very fast evolution. Okay, so these are various criticisms of Darwin's theory after it came out. And you can see there's quite a lot of them, and they're mostly scientific criticisms. They're not sort of theological ones. Darwin's theory of inheritance, that is how traits sort of get passed on from the parents to the offspring, was known as pangenesis. Interestingly, it actually included the Lamarckian view that acquired characteristics can be inherited. That view is now sort of the one part of Lamarck that everyone remembers. So it's funny that in that sense, Darwin was also a Lamarckian, but Darwin didn't believe the crazy stuff in Lamarck. And it turns out that there is some of this anyway, so-called epigenetics. Yeah, but the important point about pangenesis that caused problems for Darwin is the idea that if the parents differ in some trait, like height or color or something like that, amount of fur, then the offspring are going to get a blend, sort of like a half and half mixture from the parents. And this was problematic. Basically, this is the swamping argument from an engineer called Fleming Jenkin. And so suppose you've got a population where everybody's kind of the same, and then suddenly some kind of mutation or something occurs so that, I guess it wasn't genetic mutation there, this is before Mendel, but you know, some random variation occurs so that there's one animal in the population now that is superior to the others. What's going to happen? Well, it has to breed with these ordinary lesser beings, okay? And so the next generation are only going to be half as good as the original one, and then the next generation they're only going to be 1/4 as good, and so on. After a few generations, that sort of extraordinary quality that this one creature had is all sort of blended away, okay? It's sort of swamped by the mediocrity of the surrounding population. Okay, so I've got a picture here. Wait. Okay, so there's a picture coming up. Sorry. Yeah, so you can see there's a number of pretty solid sort of objections to Darwinism. And so it's not too surprising that not too many people were convinced by the theory of natural selection. Now, the numbers were much better for people convinced that some kind of evolution has occurred. All right, basically everybody between 1859 and let's say 1930, pretty much all scientists came to accept transmutation, which didn't cause too many theological worries for anybody. And also, I mean, there was some worries with the fossil record and other things, not really playing ball with that, but it was relatively free of scientific problems as well. The scientific evidence in favor of it, particularly with the geographical distribution of species on the Earth, the way that new species always seem to crop up in the general vicinity of old ones that they're similar to. I mean, why would that be true other than some kind of descent with modification? Okay, I haven't talked so much about that. There's a little bit about it with the Galapagos and the American mainland and so on. Anyway, that was a pretty strong argument for transmutation. But natural selection was not so popular. So that's why this kind of period is sometimes called the eclipse of Darwinism. And during this period, And again, this is why it's important to see evolution and natural selection as not the same thing, especially with thinking historically. There was quite a variety of alternative theories of evolution. Okay, I've got a list here, I think. Yeah, so theistic evolution, this is a bit of a loose term, but basically God is doing it. Now you could maybe combine that with natural selection, at least to a point, like Wallace sort of combine a bit of God with a bit of natural selection. So they're not necessarily incompatible altogether, but yeah, God has somehow got his hand on the process and it's going where he wants. Orthogenesis. So this is the idea that evolution is rather like embryonic development. It's change according to an initial program. It's sort of front-loaded. Yeah, so life has an inherent inbuilt tendency to change. It sounds a bit like more like Lamarck in a way, only this tends to be not so materialistic. This tends to be kind of maybe a theistic version that God sort of front-loaded it in such a way, like Asa Gray said, God sort of created an egg at the beginning of life that would develop into the entire tree of life over time. By the way, this term evolution technically really describes something like orthogenesis, at least in its root meaning, because evolution is apparently from evolutio in Latin, which means kind of unrolling of a scroll. So you probably know that books in the old days weren't on, you know, pages bound along one edge, but they were just on a long sheet of parchment rolled up. And so when you unroll the scroll, you kind of reveal what's already written. Unrolling doesn't actually create the words of the book. It just shows what they're there. They're all packed up tightly, rolled together. So you can't read them. They're hidden. But then when you unroll it, suddenly it's all revealed. So embryonic development, we now know, is kind of like that. All the genes are there in the egg, implicitly determining the future path of development. It's just you can't see it yet. So it looks, if you see a series of embryos from different numbers of weeks along the path, it looks like stuff is kind of appearing out of nowhere, but it's actually sort of predetermined by this sort of genetic program. So orthogenesis is like that with regard to evolution. Mutationism, yeah, so these people are sometimes called Mendelians because they came from this work by Gregor Mendel, who saw that inheritance is not like Darwin said, it's kind of particulate. There are different sort of like particles that get transmitted down the generations so that they don't sort of blend and mix the way that Darwin thought. Anyway, so when this idea of genetic mutation was discovered, these mutationists thought that it's not really selection that is driving the bus here. All that selection is going to do is fix or preserve new variants that mutations produce. So, you know, mutationist called Hugo de Vries said that selection, even if it only explains the survival of the fittest, but it doesn't explain the arrival. They arrive in the world through mutation. Okay. I'll talk a bit about the difference between the Mendelians and the Darwinists in a bit. I think it might be in the next lecture, actually. All right, so you might be thinking, well, if Darwin was sort of sidelined in 1930, then how come, you know, Darwin is so popular today? Well, there was this sort of revival of Darwinism, 1930 to 1950 kind of time. And it goes by various names. There's usually some mention of the word synthesis, like the modern synthesis or the synthetic theory or the neo-Darwinian synthesis or just neo-Darwinism. So neo means new. So this is kind of a revamped Darwinism, basically by combining it with the Mendelian theory of genetics. Yeah, so neo-Darwinism equals Darwinism plus Mendel. Yeah. Yeah, so I mean, Mendelian genetics solved the swamping problem for Darwin. Like on the left here, we've got pangenesis. So if you start out with white and pink flowers, pretty soon, sorry, white and red, pretty soon they're all going to be pink. And imagine particularly if you had just one red flower and a bunch of white ones, even if red was somehow better in that environment, eventually they're all going to be white again, or maybe white with a very, very, very faint shade of pink to it, indistinguishable from white. So it's just, you're just going to get back to where you started very soon. Whereas with Mendelian genetics, I'm not going to explain it all, but there's these little r's and the capital R's here that are like particles that can, you either get one or the other. It's not, you don't get half and half. And so even after many generations, you do have some pink here if you have one of each allele. But you still get the white and you still get the red, okay. Yeah, so that solved the swamping problem. So these sort of new traits that emerge, these new mutant varieties, they don't get blended away, but they get preserved by selection. Yeah, and in this period, the 1930s, 40s, mathematicians, especially Ronald Fisher, developed this field of population genetics, where you can sort of mathematically analyze if a certain new trait gives you this much selection advantage, how long is it going to take to spread through the population based on the population size, the generation time, all these kinds of things. So fancy mathematics is always good for theory that makes it more kind of precise and quantitative. So that was definitely a plus for the neo-Darwinians. Yeah. Now, I just want to mention something about this. So in order to sort of understand how the Darwinians were different from the Mendelians, it might seem like they both believe, now we're talking about the neo-Darwinists, they both believe in random genetic mutation being the sort of source of variation that, that evolution needs. And they also both believe in natural selection, as picking out, weeding out the unfit. If they both believe in mutation and selection, then how are they different, right? Well, this is the key point about the neo-Darwinians, that they thought the rate of evolution is not dependent on mutation at all. It's driven by recombination, that is, sexual sort of shuffling of the genes, and natural selection. All mutation does is sort of replenish the amount of variety in the gene pool. Yeah, so somebody who's very good on this is Arnon Stoltzfus here, who's kind of reviving the Mendelian view to some extent. I don't know. Yeah, I've got a simple, you can read that, but I've got a simple summary here. So for the modern synthesis, there's the Darwinists. Natural selection is kind of like the artist, the one that kind of shapes the clay. And mutation is simply providing the material for natural selection to operate on. So it's like mutation provides the clay, natural selection shapes it into the beautiful, whatever piece of art that it's going to be. Okay. And of course, natural selection is in Dawkins's phrase, a blind watchmaker. It shapes it without any conscious plan or anything like that. Whereas for the Mendelians, it's actually mutation that's the artist. Mutation is what actually creates novelty. Mutations create eyes and wings and so on. And selection is just like a fixing process. Again, we can think about art here. If you make a beautiful charcoal drawing, you might know that you've got to be careful when it's finished, because if anybody touches, it's going to smudge and smear. So then before you let anybody else near it, you spray it with a special spray that kind of coats it with a clear layer, and then it won't smudge anymore. It fixes it. Okay, so it's kind of like that. Once something new gets created that's useful, selection will just stop it from being decaying and eroding and disappearing again. It'll preserve it down through the generations. But selection doesn't create those new things like eyes and wings. It just preserves them. Yeah, so I think this is a nice phrase from Stephen Jay Gould here, the essence of Darwinism, and here he's including neo-Darwinism, is its claim that natural selection creates the fit. Natural selection is the artist. Natural selection is the source of functionality in biology. Variation is, it's just the raw material. Okay. Natural selection is driving the bus. All right, so the next one will be sort of bringing this to the present day and making some more kind of philosophical commentary on it.